Okay, in this example we're going to graph a linear system of inequalities. And in part 1 of this question, it's asking us to take that first inequality and enter 2 points on the boundary line. I'm going to show you how to do this if you're solving for y. So let's take that first inequality and solve it for y. When we solve for y, we don't have to use the inequality symbol. We can just replace that with an equal symbol, because all we want to know is how to graph the line. So I'm going ahead and writing it without the inequality, and it looks to solve for y, all we have to do is divide by -2. We'll do that in all 3 places, mark it out on the left, and that leaves us with y equals 3/2 x plus 6. Everything's positive because the 2 negatives cancel each other out and become positive. Now, if you're familiar with graphing this, you know that you can look at the 6 and know that that is a y-intercept, so you can graph that at 0, 6 on the graph. I suggest if you're doing this problem on a computer that you do the graph on some graph paper, because it's going to help you find the points. Take a look at the slope. That's telling us to go up 3 and right 2 from that first point. So on the graph, I'm going to go up 3 and right 2 and plot another point. Then I'm going to take a look at the graph itself and see what point did I just plot. Well, that's 2 to the right and 9 up, so I just graphed 2, 9, and that's my second point. So when I have to enter 2 points on the boundary line, I can enter that 0, 6 and 2, 9, and it'll draw the line for me. Now, we're going to actually finish the example as if we're drawing the lines ourselves. So I'm going to check the original inequality. I want to see what the symbol is. The symbol itself doesn't have an equals. It's just a less than. So that's going to make us draw a dashed line. So I'm going to draw a dashed line in between those 2 points. Continuing on, what we do to see which side we have to shade, we're going to check the point 0, 0. 0, 0 is right in the middle of the graph, and it's to the right of that dashed line, so we're going to see if it's true. Take the original inequality, that -2y is less than -3x minus 12. Plug that 0, 0 in, so just put the zeros in for x and y, and simplify it. You get 0 is less than -12. Well, that's not true, that's false. So going back over to the graph, since that point's false, that whole side is false. So we're going to shade the other side. That's the first line. Now let's do the second line. Again, they're wanting us to enter 2 points on the boundary line, so we're going to follow the same steps. Solve it for y. Go ahead and write the line with an equals in it instead of the greater than equal to. In this case, the negative in front of the y has to go, so we're going to divide by a -1 in all 3 places. Cancel. This is going to leave us with y equals -4x minus 8. Take a look at the -8. That's going to give us our y-intercept, which is 0, -8. That's one of the points. Put that point on the graph. Then look at the slope. The slope is -4. We really can't go down on the graph. I'd like to go up, so I'm going to move that negative to the bottom of the 4, so you can always put a 1 under with a negative or a positive depending on the situation. In this case, we want to keep the slope negative, so we're going to do +4 over -1. That's telling us we can go up 4 and to the left 1. When we go left, we're actually keeping the slope negative. So on the graph, we're going to go up 4 and left 1 and plot another point. Let's take a look and see what we plotted. That's 1, -4. And now we have 2 points that we can enter for the boundary line. So we can enter the 0, -8 and the -1, -4. The next thing we're going to do is take a look at the inequality, and it's an equals to, so we are going to make a solid line, draw a solid line through those points. Then check 0, 0 again. 0, 0 is to the right of our solid line. So let's see what happens when we plug it in. Write the line down, go ahead and plug your zeros in, and simplify, and you get 0 is greater than or equal to 8. That is false. Because that's a false statement, that makes my point on the graph false. So the right-hand side's false, and we're going to actually shade the left-hand side. So as you shade the left-hand side, you notice that you overlap the shading in the upper left corner, and that's the final solution to our problem.